Are lab gloves distorting microplastics data trends? Microplastics research is facing an unexpected credibility check. As scrutiny around plastic pollution grows, scientists are starting to question whether a basic lab habit, wearing disposable gloves, could be quietly distorting the data used to measure it. That matters beyond the lab. Governments, investors, and companies are increasingly relying on microplastics data to guide regulation, reporting, and strategy. If the numbers are off, the decisions built on them could be too. When contamination comes from the lab itself, gloves have long been treated as essential in lab environments, used to shield samples from outside interference. But recent findings suggest they may be doing the opposite in microplastics research. Residues from glove manufacturing, particularly stearate salts, can transfer onto samples during handling. Under common analytical methods like infrared and Raman spectroscopy, these substances can closely resemble widely reported polymers, such as polyethylene. In testing environments, even light contact has been shown to generate thousands of false positives per square millimeter. Far from being trivial, that level of interference has the potential to compound across samples, incrementally inflating reported concentrations. The challenge is amplified at smaller scales. Many of these residues fall below 10 micrometers, the same size range that draws the most concern for environmental and human health impacts. At that level, differences in structure and chemistry become harder to detect, making contamination difficult to separate from genuine findings. A data problem with business implications. The issue points to a broader gap in how microplastics are measured. Standard protocols have focused heavily on preventing contamination, yet glove use, widely recommended across existing literature, may introduce a consistent source of error. Even tightly controlled studies are not immune. Variations in glove composition, manufacturing processes, and how samples are handled can all influence contamination levels. That variability complicates efforts to compare results across studies or build standardized datasets. For companies, the ripple effects are real. Microplastics reporting is becoming part of ESG disclosures, supply chain assessments, and product impact evaluations. If methodologies differ or produce inflated results, benchmarking across peers or over time becomes less reliable. The conversation is now shifting towards solutions. Some researchers are reducing glove use where safety allows or switching to lower residue, cleanroom-grade alternatives. Others are focusing on improving detection itself, expanding spectral libraries, refining matching techniques, and applying statistical models that better account for uncertainty. These changes won't eliminate microplastics as a concern, but they could reshape how the problem is quantified. As measurement tools improve, previously reported figures may need adjustment, not because pollution is disappearing, but because it's being measured with more precision. For decision makers, that distinction is critical. When environmental data drives investment, compliance, and strategy, the quality of that data becomes just as important as the issue it represents.